So an official warm welcome to our NRICH Live event this afternoon. Let me introduce myself. My name's Liz. I'm a member of the NRICH team here and the primary coordinator, and I'm delighted to be joined by Ems, who's the director of NRICH, and Charlie Gilsdale, who's the secondary coordinator. We are very grateful to Trinity College here in Cambridge, who are funding these webinars so that they're free to you to join us. So we do want to mention that. The idea this afternoon is that we're going to introduce you to some of the new problems that are in our latest features, all of which focus on quadrilaterals, in particular visualizing quadrilaterals. And we hope that you will be inspired to try out the tasks with your students in the classroom, even tomorrow. Throughout the session, we'll be inviting you to participate in the mathematics via the chat. So do please do that. And as usual, tentative ideas are very welcome. We don't, we're not looking for fully formed and reasoned solutions necessarily. So do offer your current thinking at any point. Charlie, is there anything that I've missed out in terms of general intro that you'd like to chip in on?
I don't think so.
Okay, fantastic. In which case, let's get going. So what I'm going to do is I'm going to share my browser screen, and so we can see the NRICH site live. Charlie, could you nod at me or indicate whether or not you can see the NRICH website? You can, fantastic. Okay, so this is the homepage of NRICH, and the activities that we're going to have a look at today, we're really excited about. As I say, they focus on visualizing quadrilaterals. One of them is a game that has been on the NRICH site for really quite a long time, but our colleague, Oscar, has been working very hard to redevelop the interactivity and has worked on some accompanying resources so that we've got a little suite of 3. Now, what I'm going to do now is I'm going to go to the primary teacher homepage, which is this green button at the top here. And I'm going to navigate to the latest feature, which is this blue box, top right. And here we are, so picturing quadrilaterals. Now, although I've come to the primary feature, I do want to make it clear straight away that you will find analogous resources in the secondary feature, and we will look at the secondary feature in more detail a little bit later. You can see if I scroll down, the game that we're going to start with is called Seeing Squares. And we'll say a little bit more about the analogous secondary resources shortly. So I'm going to click on Seeing Squares. And if I scroll down a little bit, we're going to be taken to this beautiful new interactivity. Now we have a game here. Charlie and I are going to demonstrate the game for you. We're going to play against each other. The game is set up by default to play the computer against the person. So because we're going to play against each other, I'm going to click on the top. Is our settings menu. You'll find those all over NRICH Interactivities, and we're going to just change this to human versus human. The other thing that I think I am going to do is to click axes on. So this will just help us refer to the grid a bit more easily. Okay. So Charlie, we're going to take it in turns. We're going to choose a spot on the grid. I'm going to be very kind and I'm going to let you go first. So you're going to have blue triangles. I'm going to be placing pink squares. And the aim is for you to get 4 of your blue triangles at the corners of a square. If you do that before I get 4 of my pink squares to form the corners of a square, you win. Those of you participating, we're going to demonstrate for you how to play, and then we're going to set a few challenges for you. So Charlie, go on, you can go first.
Well, I sort of feel I ought to let you go first, Liz.
No, go on, you can.
Okay, I'll go for the point 5-2.
5-2, okay, 5-2. Here we go, right. So now I'm being told it's my turn, player 2's turn. Okay, I might go, I think I'm going to go 3-3. Over to you.
Okay, I'll go for 5-4.
5-4, right ho. Okay. Oh gosh, right. I'm gonna go maybe 3-4.
Okay, I'll go for 2-4.
2-4, 2-4. It's funny when I'm doing this on your behalf, I have to try and stop myself preempting what you might want to do. Okie dokie. I'm gonna go. I might go 4-3.
Okay, well, I have to go for 4-4.
That's a shame. I was hoping you wouldn't notice that. Okay, instead, I'm going to go for 3-2.
I think I'm going to lose here, Liz. I think you can complete 2 different squares. I'll go for 4-2. Maybe I shouldn't have said that you were going to. Okay, 4-2.
Okay. I think possibly I could win. I wonder whether anybody participating can help me out here.
2-3.
Thank you. Whoever said 2-3, let's have a look. Yes, there we go. Okay. Now, we're going to stop there. It's over to you now. We'll have a little chat in a minute about some things that come up, but we'd like you to have a go playing yourself. Charlie, you look like you'd like to say something though. No?
Well, yes. So we'd like everyone to play against the computer.
Yes, please.
And what would be really interesting is to know whether anybody can find a winning strategy to beat the computer. Often when we play against the computer, I tend to lose about 8 times out of 10.
Absolutely.
The computer is much better at this game, even if I'm given the opportunity to start. So it'd be really nice to know whether anybody's got, after playing the computer a few times, whether they can find a winning strategy.
Yeah, so just to remind you, we went to get here to this task, we went to the primary teacher's homepage, we clicked on the latest feature, top right, and we've chosen seeing squares. So if you'd like to, on your own device, have a little go at playing against the computer, when you go to the interactivity, it will come up automatically playing against the computer. We'll give you a few moments, and do post in the chat any ideas that you have about a winning strategy. So off you go.
I'll put the link in the chat as well, Liz.
Great idea. Thank you so much, Charlie.
Okay, it's in the chat now. Liz, I can see that somebody called Harriet says that she's played this with her students and that they definitely have a winning strategy and they worked it out. So
I spotted that too, Charlie, and it might be interesting to hear from Harriet shortly, if Harriet doesn't mind.
What's not clear, Liz, is whether her students have got a winning strategy or whether she's got a winning strategy.
Yeah, thank you, Harriet. That's very considerate of you. Very considerate of you. And I like the way that Vali, I hope I've pronounced your name correctly, is very honestly explaining that she's lost twice already. And if this is the first time you played Vali, then that's absolutely nothing to worry about.
The good thing is we've got Oscar, who programmed the interactivity at this meeting. So if Harriet does have a winning strategy and Oscar hears about it, he may reprogram it so that the computer gets even better.
If you have any tentative thoughts about what you think could be a good idea, you know, it could be the beginnings of a strategy, as we said right at the beginning, even if it's not fully formed, it would be lovely to hear. Similarly, perhaps if you're striving to work in a particular way, but you're not quite managing it, that would also be interesting to hear about. You know, maybe you've got something in mind that you're trying to do, but for whatever reason, it's not quite working out yet. There are a couple of people who just popped into the meeting. I'm just going to pop the link back in the chat. We're having a little look at this interactive game, or Seeing Squares, and we're inviting everybody to have a go against the computer and to have a think about a strategy that you could develop for winning the game, for beating the computer. Perhaps shall we have a few more minutes and
perhaps people could put in the chat whether they'd like to have a go at playing the game against a computer in a sort of public forum. Liz, presumably you could you could carry on sharing your screen and
absolutely.
And do you want people to type the coordinates in their chat? Is that the easiest way to do it?
Yep, that would be great. Yes, if anybody's prepared to volunteer, then that would be lovely. If not, we could possibly invite Harriet to, although I don't want to put you on the spot too much, Harriet.
I want to know whether Oscar can beat the computer, given that he programmed the computer. Does he know whether the computer has got a weakness, a weak spot?
Oscar sounding confident. Okay, I think, should we have 1 more minute? If there is anybody who'd like to volunteer to have a go against the computer, we would be delighted. Or alternatively, if you've got a few pointers that you'd like to type into the chat about what you're thinking about, how are you trying to win, that would be fantastic too. And then we'll come together in a minute or so again.
I'm assuming that the silence means that everybody is struggling to beat the computer, but
it's interesting, isn't it? Yeah, we're I wonder if that is the case. Harriet's offered a tip. That's interesting, Harriet. Oh, that's very honest of you. Thank you, Kyoto. Apologies that I might have pronounced your name wrong. Harriet, I think I know what you mean, but perhaps I wonder, I might invite everyone to try and drag themselves away from, yeah, the confessions are coming out now. to try and drag yourselves away from trying to beat the computer, and let's have a think all together again. A couple of people are mentioning a T. Yes. Okay, but it seems to work less than half the time. Oh, that's not good, Claire. That's interesting. So yes, that's a good excuse, Michelle. The Monday tiredness. We'll buy into that. I wonder now. I might. I tell you what. Harriet, would you mind sort of being our demo player, if you like? I'm only picking on Harriet because you've admitted, Harriet, that this is not the first time you've had a go at this game. So I really hope you don't mind.
No, more pressure.
Right. Okay. It's not. No, you shouldn't feel you're under more pressure at all. We're all friends together here. What would be helpful, though, Harriet, if you don't mind, is if you could offer the the coordinate that you'd like to choose, and I'll refresh the screen, and we'll change the settings. In fact, we possibly won't need to now. Let's just double check. So there we go. We're set up to go.
Liz, you could zoom in a little bit, because
yes, okay.
Yeah, I think that's a bit better, but we'll need the axes again.
Oh, yes, thank you. Let me get the axes on. Okay.
Gabriel has been defeated wonderfully many times.
So, Harriet, would you like to go first? We're set up to go first.
Okay, 3-3.
3-3. Okay, let's see what the computer does in response. 2-4, the computer has gone. Your turn again, Harriet.
Okay. I'll go 5-5.
5-5, okay. So the computer's gone 5-3. Harriet, are you able to articulate what you're thinking about, how you're trying to choose the points?
Okay, so I think I've just messed it up, to be honest. So what I was trying to do, I was trying to get what somebody else I think was talking about, the diamond. So, or I think of it as being a T shape. So the top of the T, as in if you'd write it as a capital, trying to get that in different orientations, and then you can put the sorry, I'm being very inarticulate here. Then you can put the stick of the T in, and it'll give you a two-way trick, a bit like you did. You did a two-way trick across it, but it was more disguised because the moves are taken prior to it.
Okay, so a two-way. Sorry to interrupt.
Yeah.
A two-way trick. So in other words, what you're trying to do is set yourself up so that the computer, you have got the possibility on your next turn. There are 2 possible places to go. Both of which would create a square. So the computer is forced to stop one of them, it's forced to block one, but cannot block both in one turn. Okay.
Yeah. But what happened, because the computer has gone to 5-3, there's a slightly smaller grid than I'm used to playing on. I haven't got space either side, if that makes sense. So
what's interesting about what the computer has done, Harriet, is that the computer might have been thinking that you would go to 4-4 and to 3-5, for example, because that would give you a T. I mean, an upside down on an angle T, because then you would have also had the opportunity. Somehow, you know, Oscar has managed to program the computer to more or less guess that that would be an option, and that and has sort of blocked your T's.
Exactly, which is very annoying.
Yeah, well, Oscar's here, so you can send him a message on the chat.
Sorry, it's very clever, I should have said, rather than very annoying. Okay, so I'm kind of slightly stuck now in terms of, I'm a bit annoyed by that last move. So
if anybody, Harriet, we could invite other people to post, if anybody has got a suggestion for a coordinate, do please pop it in the chat. If you'd like to, if you've got a suggestion of where Harriet could.
I think I'd go 3-1 next, would be my next choice.
3-1, well, let's go for that. Right, let's see what the computer does. So the computer's gone 4-2.
So in which case, hang on, I'm going to get beaten by the computer.
It's okay.
I'm now going to go 1-3.
I'm just thinking, Harriet.
Yeah.
Oh yes, because then you've got the.
No, don't want me to go there. I'm open.
Yeah. No, that's That's.
We try that 1-3. This computer's blocked this square, unfortunately.
Yeah. So my other 2 triangles that way is this annoyed. It's interesting playing on a slightly smaller grid, actually. It does change things quite a bit.
Yes, so, it is certainly worth experimenting with different size grids. It's a good point.
Yeah, I think I'm just going to play chase, and eventually it'll give me a square I'm not used to. So if anybody else wants to have a go, my next instinct was to go 2-2, then the computer will go 2-3.
Okay, to block this. Yeah, okay. Well,
yeah, but I'm playing chase with the computer, really.
Let's see.
Oh, well, there you go. Lost.
Ooh. I wonder if anybody else spotted that, but was too shy to point it out. Interestingly, I didn't say. Very honest, Valley. Very honest. Once again, what is interesting is the tilted square. It does make it harder to see. There are some lovely conversations to be had here around how do we know that's a square, which you might expect pupils at different levels of experience to explain in different ways. What do we know about squares? How can we convince ourselves that it is a square and not? Harriet, I'm going to use the example you talked about, a diamond. my mantra is that diamonds exist in jewellery and not in maths.
I didn't say diamond at any point because I hate the word diamond. I'm sorry.
Oh, didn't you? Oh,
No.
sorry. What did you say?
I said a triangle at one point, but no, I agree.
I'm so
diamond.
sorry.
No, I completely with you on this.
I'm so sorry. I thought you had, so I'm really sorry if you didn't.
No, sorry.
But yeah, okay. Many children might describe this as a diamond. So it's a really useful opportunity from that point of view. Thank you so much, Harriet, for putting yourself in the spotlight and having a go. Charlie, is there anything you'd like to say following on from?
No, I think given that Square It is an interactivity that some people might have known before,
yeah.
I'm quite keen to move on to seeing parallelograms,
yes.
because you and I need a bit of help here, because we've never managed to beat the computer when we've gone second. So I'm wondering whether we challenge everybody to have a go against the computer. I'll put a link to seeing parallelograms.
Thank you.
In the chat.
Thank you. Or alternatively, if you're still on the Seeing Squares page, then you can use the link at the very top of the page. We've got a direct link to Seeing Parallelograms, which takes you to a very similar page with an interactivity once again. And if you, and as Charlie said, we'd like you to help us beat the computer when we go first.
No, so when the computer
when we go second. I'm so sorry. I'm so sorry. So sorry. When we go second, and what you will need to do, possibly then, if you want to, you may not want to straight away, but don't forget you can use the settings, the cog, the settings menu to change who goes first and who goes second.
But also Harriet was talking about increasing the size of the grid.
Yes.
You can also do that.
Yes, you can. So that's our challenge to you. Can you help us to beat the computer when we go second? Have a play for a few minutes. Once again, if you gain any insight, please do post some thoughts on the chat and we'll come together in a few minutes. That's great, Stephen. Well done. Yes. So you've gone first and you've won on your first try. Brilliant. Can you help us beat the computer then if we go second? That's your challenge now. I will wish you luck. Good luck. That's an interesting statement, Maria. Maria thinks it's impossible to win by going second. Valley has suggested that surely it's easier to go first. Andy, that's a really good question. Is a square an example of a parallelogram? What do others think? Is a square a parallelogram, I wonder? I guess if we think about what a parallelogram is, Alan is saying yes, Valley is saying yes, Maria is saying it has two sets of parallel sides, absolutely, yes. So if, by the way, what you may want to have a look at is on the, I'm just going to scroll up here, on the left-hand side in our menu on the left here, which is the same for all NRICH paths. If you look at the getting started section of seeing parallelograms, there are some images which may be useful to share with students to address exactly that kind of question.
Yes, it's not quite an animated set of images, but the idea of the first one is you can start with a parallelogram, which is a little bit lopsided. I think of it as a parallelogram early in the morning, waking up and getting up. In the middle of the day, it's upright, and then towards the end of the day, it's feeling a bit sleepy and falling asleep again. But somewhere along that trajectory, it's got angles of 90 degrees. So the bottom left angle is greater than 90 to start with, and it's smaller than 90 at the end. But at some stage, the angles are all 90 degrees. So the rectangle is one special type of parallelogram. And likewise, we can start with a parallelogram and go sort of squishing it, to use a really technical mathematical term. And somewhere along the way, we have a rhombus where all the four sides are the same. And likewise, a rectangle can be squished and be a square at one stage. So we hope that those are helpful. I think I can show that if you go first, you can always win, Liz.
Okay, yeah, sure. Well, I think that would be an excellent avenue to pursue. It's interesting how we've got a range of opinion here. Some people are saying that it feels impossible, but they can't quite prove it yet, which is, thank you for sharing that. You know, that's where it all starts, with the conjecture, even if we can't actually prove it yet. We've got some people saying that it feels like you get into the situation where the computer has set up the two possible options very quickly. So Charlie, would you like to have a go?
Okay, so, but later I'd love to see what Richard is doing.
Yes.
Get the computer to draw in a straight line, because I don't understand what's happening, but I'd be interested.
No, I that would be interesting to pursue, wouldn't it? Yeah. Okay.
Now, I better warn you, Liz.
Yes.
I haven't tried this explanation on anybody.
Okay.
And I want to share my screen and draw. Because,
okay, fine. You're sorry. Yes. All right. I'll stop sharing then.
So this is me, I think, trying something out here that I've been sort of trying to picture. Okay, so here we go. I want to start by just saying I'm going to sort of randomly stick 3 dots anywhere. And of course, if I'm going first, the computer won't have been able to complete a parallelogram in the time that it takes me to draw 3 dots. So I don't really care where the computer has stuck put its dots. But let's imagine that I've put those 3 dots there. Why is it that the computer, why do I think the computer's not going to be able to stop me? And I think my thinking goes something like this, that if this here is going to be one side of the parallelogram, of the winning parallelogram, then the other side could be there or there. So I've got two other points that it could be at. But I might decide that this is not going to be one side of the parallelogram, that this is going to be one side of the parallelogram. And so if I decide that's going to be one side of the parallelogram, then the other side could be there or somewhere like there. And again, I've got an extra point. I think these might coincide here. But I could also be saying, oh no, I want, oh no, well, okay, so if that's one side, then maybe that's and that. So I've got three possible, I haven't done this accurately enough, and perhaps I should have rehearsed this, but because I've got three possibilities, the computer might be able to stop me doing one of them, but it's never going to be able to stop me doing all three. So it's like you would, people were talking about the T for making for the squares. Here, irrespective of where I put my first three dots, I'm always going to be able to find the computer's not going to be able to, or my opponent is not going to be able to stop me, because I've got so many other possible parallelograms. So I can have I can have this parallelogram here, or I can have that parallelogram there, or I can have a third parallelogram. So maybe yes, there are three possible parallelograms that I can have, and so that's why the computer can't stop me. However, Richard has been beating the computer, so I'm going to stop sharing, and maybe Richard can talk us through what he's doing.
Okay, so what I was doing was, I've taken a photo on my phone. Let me just.
Liz, do you want to share your screen again?
Yeah.
Um,
Is it helpful to share my screen, Richard, or would you want to?
yeah, no, you can do. I took a photo on my phone, so I
Okay.
could. So basically, I just went in the middle of the square. So I played on a 9x9 grid.
Okay.
And the computer went first, obviously.
Yeah.
Liz, do you want to put a 9x9 grid on, just in case it makes a difference?
I don't know if it makes a difference. So
Okay. So
Do you want to put axes so that Richard,
yeah, I'll put axes on. Should we let the computer go first and we'll go second then, and see if we can replicate what you've done, Richard?
it doesn't work every time, but I've done it twice.
Okay.
So the computer generally chooses to go on the middle line.
Right.
And all I did was I went to the bottom on the same line as them. So 4-0.
4-0. Okay.
Then when the computer did it next, it went underneath.
Yep.
And what I did is I went to 8-0.
Okay.
When I did it when it did it then, the computer just went a bit on top of it like that.
Okay.
I went 8-1.
Yeah. But if the computer hadn't done that, then you might have been, because if the computer had gone anywhere else, you would have been in trouble.
Yeah.
Oh well.
So
Richard, I've got bad news for you. Oscar's listening to this. Chances are this is not going to work tomorrow. But carry on. This is fascinating.
So I had a couple of options. I could have gone 8-8, or I could have gone 8-1. So I went to one of those ones.
Okay, let's go 8-8.
Okay. So this time it's figured it out for me, so it hasn't. So then I went back to 8-6. So here, unfortunately, it's figured me out this time. So I went 0-0. So now I'm going to go 0-8.
Mm.
But also, Richard, I think if instead of 8-6, you'd gone 8-7, you could have
Yeah.
won.
Yeah, I mean, obviously, I forgot that it's a square, but that was the sort of strategy I was doing. I've done it a couple of times with different sort of smaller and larger sort of rectangles.
That's interesting.
That
But
is
it
interesting.
doesn't do it all the time. Sometimes, but generally, if I started going in the same line as what the computer started, I had like a 50% ratio. If I didn't, then I'd tend to lose straight away.
Okay. Mm. So I think what we're saying, yeah, this is really interesting, and I'm sure Oscar is taking note.
Having said to Oscar this morning that he wouldn't have to do any more work on these interactivities, it's back to the drawing board. Okay, Oscar's responded in the chat.
All right. Okay.
Aha. Okay. Thank you, Oscar. Thank you, Oscar.
You just said solve it, so.
Okay, yes. Liz, I'm
Yes.
aware of the time. I want
Fine.
to
Yes.
give everybody a chance to play rhombuses.
Absolutely. Absolutely. So thank you very much, Richard, for sharing that strategy with us. Thank you, Oscar, for responding. We've got one last related interactivity to share with you. And this is seeing rhombuses, or rhombuses is the secondary version. So again, you could go to the top of whichever task you happen to be on at the moment, and you can click through to seeing rhombuses. I'll also put a link to that in the chat. So do have a quick explore of that. Can you find a strategy to beat the computer this time? We'll just spend a couple of minutes, and if this might be one that we will leave you to explore in more detail in your own time. But have a couple of minutes now. Any insight, again, please post in the chat.
And do we have anything in the getting started here, or is I can't remember whether we put something. Yes.
Yeah.
Federico's asked about going first, and I think yes, here we're very happy for you to go first. So as I'm concerned, Oscar and the computer have been thinking about this a lot longer than us. So I think we all deserve the chance to go first. That's interesting that Harriet has also talked about the 9x9 grid. So that's really useful feedback for us and for Oscar.
Absolutely, Linda. When we were designing the games, that's exactly one of the points we were trying to bear in mind to make sure that was reflected in the game. So yeah, absolutely right. This idea that the a square is both a rhombus and a parallelogram.
I've now convinced myself, Liz, that if I put 3 dots randomly that are not in a straight line, I can always draw 3 different parallelograms.
Okay, good.
Which is sort of why it's so difficult to stop somebody. Well,
yes.
Why if you start and you just put 3 dots randomly, not in a straight line, it's going to be impossible for the other person to stop me.
Do post any insights that you're experiencing, that you're having about the rhombus game.
And do let us know if you've managed to beat the computer.
Well, Valley did, but she seems to be quite honest to say, not perhaps without a strategy at this stage. Which, but I wonder whether you could use. It really was luck. I wonder if you could analyse what you did do, though, Valley. One of the features of the interactivity which we haven't mentioned is the fact that once a game has taken place, you do get the chance to click here at the bottom right on the game report. So you will get, let me just very quickly, don't worry about paying any attention to what I'm doing. I'm just going to have a quick game just so that I can show you what a game report looks like. So the game report gives you a record of the turns each player took. So I wonder, Valley, whether you could, obviously you may not have realised that existed, but perhaps in future, if you did win without realising, without having a particular strategy in mind, looking at the game report afterwards might help you analyse what happened to be useful about the way that you played.
But it also might be useful letting the computer go first.
Absolutely.
Looking at the game report and trying to figure out why the computer did what it did, and then go first and see whether one can replicate the computer's strategy. Exactly,
Charlie. Yeah.
But I suppose if anybody finds a consistent way of beating the computer, it'd be quite nice if you could email us and let us know, because chances are that Oscar might then be keen to program the computer so that it doesn't get beaten.
I'm going to draw everybody back together, and actually I'm going to follow up on what you've just said, Charlie, because although you as teachers taking part in this webinar may well find a strategy, perhaps your learners would do too. And these 3 tasks that we are offering to you, we've shared with you now, are all what we call live tasks. If I just go back to the primary teacher feature.
Liz,
yes.
Just before you do that, could you just scroll to the very bottom so that people know that if they ever want to email us, our contact details are at the bottom of the page?
Yeah. Sorry, yes. So right at the bottom on every page, there's a contact us section which gives email. The primary email comes to me, the secondary email comes to Charlie. So if you wanted to get hold of us, please do.
And we forward them all to Oscar.
But if we go back to the feature, you will notice that seeing squares, seeing parallelograms, seeing rhombuses, they are all live tasks. And you may have noticed that on the left, therefore, we have a submit a solution button on each one. So your students could send us their strategies, which would be wonderful to hear. We would suggest that they, before they share their strategies with us at NRICH, they'd share their strategies with a classmate, with you as the teacher, that you can check them out. But we'd be delighted to hear from your students as well as from you about potential strategies. Just to go back quickly, what we'd like to do now, we hope having that experience of those three interactivities, you can appreciate how powerful they are for encouraging students to gain a deeper understanding of the properties of these quadrilaterals for a start, but also that strategic thinking, that working ahead, that the visualizing, the sort of the dynamic nature of these tasks can really offer challenge to many students. If you're working with younger learners, you may also like to explore some of the other tasks that we've got in the primary feature, some of which would be useful precursors to these three games that we've offered you today. For example, complete the square, polyplug rectangles, square corners. These I would recommend being appropriate for slightly younger learners. Stringy quads and 8 hidden squares go very nicely alongside these interactivities. As the name suggests, 8 hidden squares particularly lends itself alongside seeing squares. Charlie, if I share the secondary feature, or would you prefer to share on your screen and then you can talk?
No, I'm happy for you to. We don't have very
Okay.
much time, so that's fine.
So if we go to the secondary feature, I know that Charlie's keen to share with you some of the tasks that these three interactivities would feed into for older students.
Yeah, so whereas, can you just scroll down a touch? Yeah, so whereas the three primary tasks were called seeing squares, seeing parallelograms, and seeing rhombuses, the secondary version is called square it, parallelogram it, rhombus it. They've got exactly the same interactivities, and I think the text for the problems is identical. But I think in the teacher's resources, so on the far left in the menu, there's always an accompanying teacher's resources. I have linked to secondary tasks like square coordinate, opposite vertices, and tilted squares, whereas Liz has not done that because she's got a primary teacher's audience in mind. So the games are identical, interactivities are identical, everything works in the same way. The getting started pages are the same. It's only the teacher's resources which are slightly different. If we go back to the feature, then you'll also see that these three problems are open open for solutions, and these problems that encourage students to think about shapes and how do you decide whether a shape is a square when it's a tilted square, for example. Feeds into a problem like tilted squares, which many of you may have seen, which starts by recognizing that most students can work out the areas of squares where the sides are horizontal and vertical, but then challenges them to find the areas of squares which are tilted. And we've got on the screen now squares with a tilt of 1, because to go from the bottom vertex to the next vertex, you go across and then 1 up. But then what happens when you go 2 up and 3 up and so on? And there's an interactivity at the bottom of that page, I think. And this problem then leads to the generalization that we normally know as Pythagoras' theorem. And in the teacher's resources, I think there's a link to a video perhaps of a colleague and me working with some students on this problem. Yes, so there's some support material. So the game Square It and Seek Squares can be enjoyable and fun to play with, but actually there is a serious reason for doing this, which is that it's much more likely to be a good preparation for students who are having to draw tilted squares in order to work on this other problem. We've got a couple of other problems in the secondary feature. I think one is called square coordinates, which is about, and again, there's an interactivity, and you can move the vertices around. So the challenge might be to draw a square, and when you do the square, and you can show the coordinates, and basically the question is, can students come up with, notice any patterns, anything, any rules about how the coordinates work? And one of the things that they may notice is that when you look at the x coordinates of the opposite vertices, the average of those x coordinates is the same as the average of the x coordinates of the other pair of opposite vertices. You sort of get the x coordinate of the center of the square, and likewise for the y coordinates. And that at the bottom of the problem, there's a question about, can you work out which sets of 4 coordinates are the coordinates of the vertices of a square without drawing? So it leads to thinking about generalizing and about picturing squares. So these features that are about picturing quadrilaterals and visualizing quadrilaterals in this way. And there's a third problem as well, which we don't have time to talk about, but it's all there in this half terms feature. So hopefully that's useful, and hopefully some of your secondary students will have a go at these problems. Hopefully, thank you for that feedback on parallelograms. I'm sure Oscar will be delighted to receive that feedback, and he'll be going back to the drawing board tomorrow. Okay, I think that's all I want to say, Liz.
Thanks, Charlie. I think just to let you know, I mentioned earlier that we're recording, obviously, and we will put a copy of the recording of the webinar on a page which will be linked. If you go to the events page here and you follow the link, which is about previous NRICH Live events, we will add the recording to that page there for you to look at, and you can share it subsequently with colleagues should you wish. As we mentioned at the very beginning, we are very grateful to Trinity for supporting us, Trinity College. And so if you do have 2 minutes to fill in the feedback form that Ems has posted in the chat, we would be very grateful. I think that brings us nicely to the end. So thank you very much for your participation, and we look forward to seeing you at a future event. Thank you.
Bye-bye.